section number 52 is multiplication, multiplying square roots. Now, remember that the square root of a times b is the square root of a times the square root of b. But it goes the other way as well. It goes the other way as well. Let's see what I can come up with. For example, if somebody asks you, what's the square root of 12 times the square root of 3? You can say, well, 12 times 3 is 36, and I know the square root of 36. Because I know the square root of 2 squared, and 3 squared, and 4 squared, and 5 squared, and 6 squared, and 7 squared, and 8 squared, and 9 squared, and 10 times 10, and 11 times 11, and 12 times 12, and 13 times 13. I know the square roots of each of those numbers. I know the square root of 36 is 6. So sometimes you want to put it together. You want to say, well, if you give it to me like this, and I did, square root of one number times the square root of another number, I'd rather do it like that. Other times you don't want to. So it's a real headache. To ask you, what is the square root of 50 times the square root of 2? Here's a case where you do want to put it as one square root. Because I know the square root of 50 times 2. I know the square root of 100 is 10. You have the square root of 2x times the square root of x. Well, you should separate the numbers from the letters. So the square root of 2x is the square root of 2 times the square root of x times another square root of x. But the square root of x times the square root of x is x. This is square root of 2 times x. Now, we'll go over more carefully why that's x, but here's a notation problem. If you write the square root of 2x, just like that, and a lot of us would, myself included, the square root sign isn't all the way over x, so the question is, did I mean for it to be over the x, or did I mean for it to be just over the 2? Question is, I don't know. If I just see this, I'm not going to know which the person meant. So if you don't want the x to be under the radical, you really should write it in front. It's pretty difficult to argue, visually speaking, to argue why that x is under the radical sign. When it comes to this, you can argue, well, look, it's under the radical sign. Or over, if it's just like this, you can argue, well, the person meant it to be under the radical sign. They just didn't extend it long enough. But you're not going to win any type of argument over here. The x is not under the radical sign. So we should write it like that. Now, let's talk about why the square root of x times the square root of x is x. By thinking. The square root of 25 is 5. Why is that? How might you convince me? Then, why didn't the square root sign come up? The square root of 25 is 5. Why is that? Because my answer, when I multiply it by itself, it gives me 25. Why is the square root of 36 equal to 6? For one reason. 6 times 6 is 36. But you know what? There's another way of, say, writing 5. This equation there tells me another way of writing 5. Another way of writing 5 is square root of 25. Another way of writing 5 is the square root of 25. And another way of writing 25 is 25. That is, the square root of 25 times the square root of 25 is 5. Another way of writing 6 is square root of 36. Times, another way of writing 6 is square root of 36. And this equals 36. The square root of 36 times the square root of 36 is 36. Okay. Now, let's just say for a moment that the square root of x is equal to k. Why is that true? Since, just like I wrote 6 times 6, I'm going to write k times k. Since k times k is equal to what's underneath the radical sign, namely x. But what's another way of writing k? Square root of x times k square root of x. The square root of x times the square root of x is x. The square root of 11 times the square root of 11 is 11. Another way of arguing it is just from the definition. What does the square root of 25 represent? It's the symbol for a number, namely 5, but it's a symbol for a number that when you multiply it by itself, you get back 25. The square root of 11, what is special about square root of 11? By definition, if you multiply it by itself, you get back 11. The square root of 13 is that special number that just in case we multiply it by itself, gives you back 13. So that's why the square root of x times the square root of x was x. The only thing is x can't be negative. You can't take the square root of negative numbers. So if you have the square root of 25y times the square root of y, you should always separate the number from the letters. That's the square root of 25y. That's this. Times square root of y. Well, square root of y times square root of y is y. Oh, and I need another square root of 25. Square root of y times square root of y is y times the square root of 25, which is 5. The answer is 5y. If you have the square root of 18 times the square root of 5. Now, if you multiply, which is not wrong, 18 times 5, you'll get 90. But that doesn't help us. I don't know the square root of 90. So you can do it this way and say, well, the largest number on our list that goes into 90 is 9. It goes in 10 times. 9 times 10 is 90. And the square root of 9 is 3, and the square root of 10 is just square root of 10. Or, you could have said 18 is 9 times 2. Do not forget to multiply by the square root of 5. Square root of 9 is 3 times the square root of this number times square root of that number is the square root of the product. 3 times 5 is 10. Now I'll put it together. I don't want to leave the final answer as 3 square root of 2 square root of 5. So I said 2 times 5 is 10. All I'm saying is this is just 3. Square root of 9 is just 3. And then before I say I'm done, I look at square root of 10 and I ask myself, is there a number on my list that goes evenly into 10? Well, there won't be any number above 10. 9 does not go into 10 evenly, nor does 4. So that's my final answer, 3 radical 10. Just what I got the other way. I think breaking it up is a little bit easier because then you get smaller numbers. What if 5 was a very large prime number? 2,311,000. a very large number. Well then, this number 90 would be really large, and I don't know the largest prime number. I don't know the largest number on my list that goes into 18 times 3 billion. I mean, I'm only up to 169. So you really don't always want to multiply the two together. The numbers are very large. You don't want to multiply. Now, for example, if you have 98 times the square root of 7, you really don't want to multiply 98 by 7. It's going to be just below 700. It'll be 14 below 700. It'll be 886. And if I did that, well then, what's the largest number on our list that goes into 886? Well, the largest number we went up to is 13 squared, which is only 169. You wouldn't want to do that. The equal sign is valid, but you wouldn't want to do that. What you would want to do in this case is say 98 is 49 times 2. Square root of 49 times 2 times the square root of 7. And the square root of 49 is 7. And 2 times 7 is 14. And then I would ask myself, can I break down 14? And the answer is no. You really wouldn't want to multiply the 98 times the 7. You only want to multiply if you see the answer coming. Like the square root of 50 times the square root of 2. I see the 100. I know the square root of 100. If you didn't see 100, well, the largest number that goes into 50 that's on my list is 25. Goes in 2 times. There is no number on my list that goes into 2. So it just stays square root of 2. Square root of 25 is 5 times the square root of 2 times the square root of 2 is 2. Oh, 5 times 2 is 10. Just like I got before. So only multiply together if you see it coming together. If you see the future. Here I see the future. 50 times 2 is 100. I know the square root of 100. The very first problem I gave you was 12, square root of 12 times the square root of 3. I know that product is on my table. Square root of 36 is 6. If you didn't see the 36 coming, or if you saw 12 times 3 is 36, but you didn't recognize and knew the square root of 36, break down 12. The largest number on my list that I know the square root of that goes into 12 is 4. And it goes in 3 times. That's the square root of 12 times the square root of 3. The square root of 4 is 2. And the square root of 3 times the square root of 3 is 3. And 2 times 3 is 6. Just like I got before. Okay, if you see it, wonderful. If you don't see it, well then you really shouldn't multiply together unless you see it coming together. Because the numbers only get bigger. If you were asked to multiply these two numbers, 9 square root of 5 times 2 square root of 5. First you have to realize this is not really two numbers being multiplied. You're multiplying 9 times square root of 5 times 2 times square root of 5. Whether you wrote it out a second time or not, you should think that. 9 times 2 is 18 times radical 5 times radical 5 is 5. 90. 18 times 5 is 90. You have the square root of 6x squared times the square root of 6x. Well, this is the square root of 6 times the square root of x squared times the square root of 6 times the square root of x. This is the square root of 6 times the square root of x squared times, and this is the square root of 6 times the square root of x. The square root of 6 times the square root of 6 is 6. The square root of x squared, you should know, is x. What times itself 2 times gives you x squared? X times the square root of x. There is that answer. A couple more and we'll be done. You have sometimes 2 distribute. Suppose you have this. You have square root of 6 times the square root of 6, which is 6, minus the square root of 6 times the square root of 3 is the square root of 18. But you can break down the square root of 18. You can break it down to 6 times 3 and 2 times 9. But I only want to use pairs of numbers and one of them is on my list. 9 is on my list and it goes into 18. The square root of 9 is 3 times the square root of 2. Well, between here and here, you can actually factor out as 3. 3 times 2 is 6, minus 3 times square root of 2 is 3 square root of 2. As a result, that's your final answer. Let's do a couple more of these multiplication problems. Remember, if you have a sum and you square it, yes, you do get the first square. Yes, you do get plus the second square. But you get more. You get the product of the two things, a times b times 2. Now, if you have the square root of 6 plus the square root of 3, and you're being asked to square it, yes, you do get that square, which is 6. Plus, yes, you do get plus that square, which is 3. But in the middle, you get 2 times this times that. This times that is the square root of 18. And we just dealt with the square root of 18. So at first, 6 plus 3 is 9, plus 2. The square root of 18 I'll think of as the square root of 9 times the square root of 2. This is 9 plus 2 times 3. Square root of 9 is 3. 2 times 3 is 6 times the square root of 2. And then you can pull out a 3. 3 times 3 gives me 9, plus, it does say plus, and 3 times 2 is 6, times square root of 2 is 6 square root of 2. And there is your final answer. We'll do one more, and that'll be it. Suppose you have 2 square root of 5 minus 3 square root of 7, and you want to multiply this by 4 square root of 5 minus 2 square root of 7. So first we multiply those two. 2 square root of 5 times 4 square root of 5. Well, 2 times 4, of course, is 8 times square root of 5 times square root of 5 is 5. 8 times 5, 40. Okay, 40. You get what you get. 2 square root of 5, well, an understood positive times a negative is negative. And now we ignore signs. 2 square root of 5 times 2 square root of 7. 2 times 2 is 4, and 5 times 7 is 35, so its square root is 35. And you can't break down 35. No number on our list goes into 35. Nor did the number on our list go into 5 or 7. So it's 4 square root of 35. So we're done distributing the 2 radical of 5. Now we go on to the negative 3 radical 7. A negative times a positive is negative. 3 radical 7 times 4 radical 5. Well, 3 times 4 is 12, and we just multiplied radical 5 times radical 7. and we couldn't break it down. It was just radical 35. In our case, 12 radical 35. Okay, one more. I'll write down the notes down here. Negative times negative is positive. You have 3 radical 7 times 2 radical 7. Well, 3 times 2 is 6, and radical 7 times radical 7 is 7, so we get 42, plus 42. And one last line, which will be the combining of like terms, and this problem in section will be done. 40 plus 42 is 82. And the remaining terms are radical 35. If you take away 4 of them, and then you take away 12 more, you took away 16 of them. 16 radical 35. And if I'm not mistaken, only 2 goes into both of these. 2 times 41 is 42, minus 2 times 8 is 16, times square root of 35. And there's your final answer. Okay, I hope you understood this. Good luck with it.